In this recap session, we are reviewing how to solve polynomials of various order. In particular, we will solve linear, quadratic, and third-order equations. We will carefully solve one of each to refresh your memory, and if you want more practice, I have dedicated videos on all three of them. We start with the basics, solving a linear equation for x. Here we have 3/2 times x minus 5 is equal to 2x plus 3. As always, solving this equation means finding a value for x such that this equation is true. First, we bring all of the terms with x to one side of the equation, and all of the rest to the other side. Then, by factoring out x on the left-hand side, we can reduce these two terms to just one. On the right-hand side, we simply have 3 plus 5, which obviously is 8. Finally, to completely isolate x on the left-hand side, we get rid of the prefactor by multiplying both sides by minus 2, because minus 2 times minus 1/2 is equal to 1. This directly gives us that x must be equal to 16. Now to check your result and see whether you made any mistakes, you can fill in the 16 in the original equation and see if both sides are indeed equal to each other. Now we move to the quadratic equation. These are equations in which the highest power of x is equal to 2. Here we want to find the values for x for which x times x minus 3 is equal to minus x squared plus 2x plus 3. The first step is to get this equation into the right form, namely a single term for each power of x. Ax squared plus bx plus c is equal to 0, because in this form the solution is given by the well-known formula. In our example, we see that we have to do some rewriting. On the left-hand side, we compute the brackets and then move all of the terms on the right-hand side to the left by simply swapping their sign. Now that we have a 0 on the right-hand side, we simply add all the terms with an equal power of x together to get the left-hand side we want. Comparing this to the general form, we see that 2 corresponds to a, minus 5 to b, and minus 3 to c. And this means that we can now directly fill in our formula. Being ultra careful about the minus signs by strictly putting brackets around negative numbers, we get our final result. And here we have of course two solutions. One where we take the plus sign gives 3, and the one where we take the minus sign, which yields minus 1/2. These two results can then be used to factor our quadratic equation. 2x squared minus 5x minus 3 can be written as x minus 3 times x plus 1/2. And for this latter form, it is immediately clear that filling in x is 3 or x is minus 1/2 gives back 0. And this is also how your teachers prepare these exercises for you. For a third-order polynomial, there is no clean solution that always works, and it is unlikely that you can solve any such random equation when you encounter one. However, on tests or exams, obviously there will be a clear solution, and the way to find it is just to test some possibilities. For instance, let's take the equation x cubed plus 2x squared minus 5x minus 6 is equal to 0. So now, for which value of x is this equation true? Well, let's try the easiest solutions, plus and minus 1. If we fill in x is equal to 1, we get 1 plus 2 minus 5 minus 6, which is minus 8 and evidently not 0. So not the right solution. What about x is equal to minus 1? Then we get minus 1 plus 2 plus 5 minus 6, which is equal to 0. So we have found at least one of our solutions already. X is equal to minus 1. So how do we go from here? Well, because this is a third-order polynomial, it has at least 3 solutions. So how to find the two other ones? Because x is minus 1 makes this equation 0, we can factor out x plus 1 from this equation, with the remaining brackets being a quadratic equation. Now we need to determine what the coefficients of this quadratic equation will be, and we will do so by comparing it with our original equation. For instance, the only way to obtain the x cubed term is to multiply the x in the first bracket with the x squared in the quadratic equation. Therefore, the coefficient in front of the x squared will have to be 1, since we need to have just a coefficient of 1 in front of our cubic term. Then we look at the x squared term in our original equation, which has a coefficient of 2. X squared is obtained by multiplying this 1 with our x squared in our quadratic equation, but also this x with the x in the quadratic equation. Since we need 2x squared and we already have 1x squared, the second term in our quadratic equation needs to be simply x. And then the last term will be a constant term, and comparing it with our constant term in our original equation, which was minus 6, we see that it needs to be obtained by multiplying this 1 in the first bracket with the number we're looking for, and evidently this will be minus 6. So now to find the last two values of x that make this product 0, we need to solve this quadratic equation, which is much more straightforward to do. We find solutions minus 3 and 2, and therefore our third order equation can be factored into x plus 1 times x plus 3 times x minus 2. And the solutions therefore are minus 1, minus 3, and 2. And this concludes our recap. If you want more practice, I have dedicated videos on each of these equations. And as always, thanks for watching, and I will see you in the next one. Bye.